Hi, today I'm going to explain vectors. Alright, well, I'm sure you must be aware that a vector is any entity that has a magnitude and a direction for its specification. Now that is a vector. And of course we can have a position vector which has an origin. Okay, and an example of such a vector would be vector OA is equal to vector A. Alright, and also you can have another vector starting from the same origin. Let's say vector OB is equal to vector B. And this is more like a crash course, so I'm going very quickly over these, and it's not that I have to go into the theory of vectors itself, because that's going to be too long for this course. So immediately we're going to look at addition of vectors. Let's say, for example, if I give you a vector OA is equal to vector A and vector OB is equal to vector B, and I tell you to find the vector AB. Now, one of the best ways to do this is to illustrate the data on a diagram. What we can do is we can say that this is vector OA and this is vector OB. Now we want to find our target, which is vector AB. If I want to find vector AB, of course this is vector A and this is vector B. I want to find the vector AB. So how can I do this? Now, if you look at the diagram, to go from A to B in this direction, what I can do, I can go in the opposite direction. I can start from A here and then go all the way through O and then go all the way to B. So that means if I want to find the vector AB, what I'm basically saying is that vector AB is equal to vector AO plus the vector OB. You see the point? Alright, so vector AB, if you want to go from here to here, you can basically say that you're going from A to O and then from O to B. And hence we have the vector AB is equal to vector AO. What is vector AO? If you look carefully, this is OA. Therefore AO is going to be in the opposite direction. That's going to be minus A, because if OA is equal to A, AO is going to be equal to minus A. So we got then minus A plus B. So this is your answer to vector AB. I can say, if I want to put it in a much better way, you put the negative sign afterwards. So that's going to be B minus A, and here's your answer. This is how we go about and find a vector by using addition. Now, interestingly, what I can do here, I can go a lot further. Okay, let us say, for example, if I tell you that we have these vectors, so this was the question, alright, okay. Now what I say is I give you, for example, vector OC, and I tell you that OC is equal to half vector OA, and I also give you, like, let's say, for example, OD, and I tell you that the vector OD is 3/4 vector OB. Using these information now, I want you to find, okay, this time, okay, we went into finding AB. Let's say that this was the first part, and now for the second part, I want you to find the vector CD. Interesting. Okay, what I will do here, I'm going to wipe this diagram off and we'll draw it again, so we can make it a lot easier for you. There we go. Now the information I have is this. I got the vector OC as given in the question, which is half vector OA. Now if OC is half the vector OA, that means it is half vector A, because vector OA is vector A. And also if I want to know vector OD, and that's been given as 3/4 vector OB, which is then 3/4 vector B. Just border this off here. Alright. Now from these information, I want to find the vector CD. Alright. So let's go and do that. Alright. Let me just draw the diagram again, as I said. So a much bigger diagram. Let's say it's like this. This is the vector OA and vector OB. Now, if you look carefully, this vector here, the vector OA, we have the vector C, which is halfway along OA. So half OA. Now let's say that half OA is somewhere here, and I call this vector C. And then I got 3/4 OB, which is then OD. D is lying somewhere 3/4 the length of OB. So let's say 1/4 here, 2/4, which is half, and 3/4 somewhere here, approximately. So this is the vector D. Alright, and so we are looking at a vector like this. Okay, and say that this here goes like, pardon me for my drawing. And so this is the vector AB. It's not parallel, but it looks a bit like it's parallel. It's not. It's like 3/4 is somewhere there. Okay, so this is the vector D. 1/4, half, and then you got 3/4 and 1. Okay, so somewhere here. Okay. So this is your vector CD. We're going to apply the same method to be able to find the vector CD. So what can we do? Again, we're going to look at C to D. If you want to move from here to here, you are basically saying that you want to move from C to O and then from O to D. So that means the vector CD is going to equal vector CO plus OD. And so vector CD is equal to CO. I know OC. OC is half OA. There we go. Half vector A. Now I'm moving in the negative direction. It's a bit like this. The vector is going in this direction. Now you move in this direction. This was A. This becomes minus A. Right. So this is now becoming minus half vector A plus OD, and OD has been given 3/4 OB, which is 3/4 B. 3/4 vector B, and hence I got the vector CD as 3/4 B minus half vector A. Okay, 3/4 vector B minus half vector A. Here we are. That's your answer to this question. Staying on vectors, okay, I'm going to explain a very interesting concept, and I'm sure you can pause the video and you can copy this on a piece of paper so you can use it as a reference later on. Well, before we go to that interesting concept, I'm going to talk a little bit about magnitude. Let's talk about magnitude of a vector. The magnitude, also called the modulus of a vector, is basically its length. I can have a vector OA, let's say 3, 4. So if you look at this vector on a diagram, a column vector on the Cartesian plane, so if you have 0 here, let's say 1, this is your x-axis and your y-axis, let's say 3 is somewhere here and 4 is somewhere there. So you're going to point here, that's a coordinate, and here is your vector. So this is the vector OA. And I tell you to find the modulus of vector OA, often written as with this symbol, find the modulus of vector OA, or the magnitude of vector OA. How are we going to do this? Well, it's very easy. So you use Pythagoras theorem. Why? Because if you look at this, if I drop a line here, let me just put a broken line, if you have a 90 degrees, this is your x coordinate and this is your y coordinate. So we got a right angle triangle, and therefore we can use Pythagoras theorem. Very often we're going to use Pythagoras theorem. Okay, and of course now if you want to find vector OA, you're going to say it's going to be equal to 3 to the square plus 4 to the square, and you do the square root of that. This is Pythagoras theorem, and that means it is 9 plus 16, and you got 25, and therefore you got 5 units. So this is the modulus of vector OA. I don't think that's difficult. It's quite easy to remember. Okay, and we're going to take this a step further. Alright, let's say for instance now I give you two vectors. I'm still staying on magnitude of a vector. I'm sure you understand a magnitude. Magnitude is a very easy thing. Like for instance 50 kilometers per hour is a number that's a magnitude. You can get for instance I don't know if you can see it properly here, sorry about that. Okay, let's say half a kilo of sugar. Okay, these are examples of magnitude. Whereas when it comes to vectors, okay, vectors normally they have a direction. They have both a magnitude and a direction. Okay, and staying on the magnitude thing, alright, let's say you got vector OA is equal to 3, 4, vector OB is equal to -1, let's say 5, and I tell you to find the vector AB and its magnitude. When we talk about magnitude, we're saying the length of the vector. Okay. Well, we're talking about the magnitude of AB. The first thing I want to find out is the vector AB. Now we know by geometry of vectors that the vector AB we said is equal to vector AO plus OB. It's a very interesting, it's going to be very helpful if you remember this in the exams. That if there is an origin and you want to find the vector, you're going to use the geometry of vectors here. That for instance if A and B has got the same origin, then you go through AO plus OB is going to be equal to AB. Similarly, if you have vector BA and both of them starting from the same origin, both of them are position vectors, you're going to say then vector BO plus OA. You will notice that here it starts from A, ends at B, starts from A, end at B. BA, B starts from start from B, and at A. That's the order of the vectors. Now, on a diagram, okay, the vectors is going to look, there's no need to draw this diagram, but you know, it's going to straighten up things in your mind, it's going to make it clearer. Let's say this is your example of vectors, like 1, 2, 3, and then you go 1, 2, 3, 4. Okay, so 4 is somewhere here, so you got your vector OE. Now you have the vector OB. Okay, let's say -1 here because this is -1 and 5. So -1, 5, the vector is sitting here, vector AB. Vector OB. Here are the two vectors, and from here you want to find the vector AB. There we go, find vector AB. Like I said, you know, there was no need to draw this diagram. You could have just said, you could have just drawn your diagram like this, and you have OA and B. This is more like a real picture of what's going on. Alright? So, still you would have still got the same answer because you're using the bright concept. You're using this fact that vector AB is equal to AO plus OB. Right? So, we're going to say vector AB is then AO plus OB. And what is AO? Now remember you have got OA which is 3, 4. Therefore AO is going to be minus 3 minus 4. Okay? Plus OB, and OB is minus 1 and 5. So if you add these two up, you're going to get minus 4 and then 1. So this is your vector AB. Now, once you've got your vector AB, this is your first answer. And now you need to find, this is done, its magnitude. How can you find the magnitude? Again, we use Pythagoras theorem. That's what we're going to do. Alright, so let's use Pythagoras theorem. So we're just going to say that the magnitude of vector AB is going to be equal its x coordinates to the square plus the y coordinates to the square. I explained this to you, Pythagoras theorem. Okay, so the x is now minus 4 and the y is 1. So we've got then minus 4 to the square plus 1 to the square, and you do the square root of that. So this is your magnitude of vector AB, which is the square root of 16 plus 1 is 17 units. That's the exact value of the magnitude of vector AB. Still, if you want to, if you wanted to find the magnitude of AB in terms of decimals, you can still use your calculator, and the square root of 17, that would have given you 4.123 something. Alright, so there we go. So we can say the magnitude of AB is equal to 4.123 units. Let's say 4.12 to 3 significant figures, which is basically required by Cambridge examiners. Here we are, done. Right.